Okay, so you're going to need to be on the substitution method page in your blue packet. It's a substitution method at the very top. It's the second blue page. You're also going to need this page of graphic organizers. Turn the page and let's look at the practice problems. The notes for this is way more complicated than they need to be. So we're not going to look at the notes until after we have practiced the sum. Now I'm going to show you how to do 3, 6, and 9 in this video, and the other 6 you're going to practice. I'll make a video in Google Classroom like going through these 6 problems step by step, so that if you need help with one of them, you can go there in the Google Classroom. All right, so you need this graphic organizer. Now, yesterday I showed you the graphic organizer a little bit, but now I'm going to show you how to set it up and how to use it. All right, so it's just basically a big T-chart. Now, in the top left, we want to write the problem. So we're going to start off with number 3. Now, before we do, let me say this. All right, so these are 2 lines. Now, y equals 5 is going to go to the y-axis at 5. That's going to be a horizontal line. This line is going to probably be negative. I don't know. But those 2 lines are going to cross. And that point of intersection, that ordered pair, is the solution. Now, what we have to do is we have to find this solution. It's an x, y ordered pair. We have to find this solution without graphing these lines. Now, this second equation is not set up for graphing. It's not in slope-intercept form. So we're going to use the substitution method to figure out where these 2 lines are going to intersect without graphing them. So to do that, we're going to use this graphic organizer to help us keep organized. And in the top left, write the 2 equations, and the top right, write your ordered pair, your blank ordered pair. Now, as we're watching this video as a class, you can pause it wherever necessary. I'm just going to go straight through, and if the class needs time to write down, that's fine. All right, so y equals 5 is the first equation. Negative 3x plus 4y equals 8 is the second equation. I'm just going to make sure I wrote it down correctly. All right, now these 2 equations are going to be 2 straight lines. We got to find out where they cross. We're only given one clue. One of the variables is solved for, the y. So y is going to equal 5. So we're going to rewrite the other equation, and wherever we see a y, we're going to plug in a 5. So negative 3x plus 4. Now we have a y, so we're going to substitute the 5 because y is 5. We're going to substitute the 5 for y. We're going to use parentheses, and we're going to finish writing the equation, equals 8. So all we got to do is solve this equation. So negative 3x plus 20 equals 8. Now we have a normal 2-step equation. We want to get the x by itself. So the negative 3 times the x is grouped together, but the 20 is by itself. So that's what we want to get rid of first. The opposite of plus 20 is minus 20. So we're going to subtract 20 on both sides. If you draw that line to separate the 2 sides of your equation, that is a fantastic idea. So we'll cancel that out. We still have a 3x. I'm just going to bring that down. I'm going to bring down my equal sign. 8 and negative 20. We have more negatives. The answer is negative 12. Now we can get rid of that times 3. The opposite of times 3, or the inverse of times 3, is dividing by 3. So the 3's cancel out. 3 divided by 3 is 1x equals negative 12 divided by 3 is negative 4. So now we figured out part of our answer. You know, the x value is negative 4. X is the first term in our ordered pair. It's always x, then y. Now we need to figure out what y is. So in the 2 equations, the top one is easier to solve for y because y is already by itself. Y equals 5. So we already have our y. So y equals 5. So these 2 lines, when graphed, will intersect at negative 4, 5. So this is just another way of finding where 2 lines cross, but we're not graphing them. All right, so let's look at the second equation. X equals 3y, and x minus 3y equals 0. So we're just going to write down the equation. X equals 3y, and x minus 3y equals 0. And our ordered pair for our solution. I'll make sure I just wrote it down correctly. And now we're going to solve this one. x equals 3y. So that's our hint, because this variable is already by itself, that x is 3y. So in the other equation, wherever I see x, I'm going to substitute 3y, because x is 3y. So in the other equation, we start off with the x. X is 3y. So instead of x, I'm going to write 3y. I'm going to put that in parentheses, just to get in that habit, even though there's nothing to do with it. Minus 3y equals 0. Now, there's nothing to do with the parentheses, so we can ignore the parentheses. 3y minus 3y equals 0. And bring down our equal sign, bring down our 0. Now, this is one of the special circumstances that we're going to spend more time going over just these tomorrow. But 0 equals 0. Now, when we graphed lines, sometimes we had two lines that were parallel. So they had no solution. They never touched. And sometimes we graphed two lines and they were directly on top of each other. And that had infinite solutions. Okay. Now, if you come across this where both variables cancel out, if this is a true statement, that is going to be infinite solutions. Like 0 equals 0 or 3 equals 3. If it's an untrue situation, like 4 equals 3, because 4 does not equal 3, that's false. So there is no solution. Now these are special. You don't see this very often, and we're going to go over these tomorrow. I think you'll see one other of these. So it's no solution because the lines are parallel, and you'll have an untrue statement. Not true, not true. No solution, not true. True has infinite solutions. I'm going to have a great video from the Princess Bride to help you remember this. All right, so the next problem we're going to go over is number 9. Y equals negative 3x. I'm going to write this down. Y equals negative 3x, and 4x minus 2y equals negative 20. All right, so I wrote it down. Get this away a little bit. Okay, so we have a hint. So we have a small clue that y is negative 3x. So if we look in our other equation, we have a y. So we know we can substitute in for that y. Y is negative 3x. So we're going to rewrite this equation, but instead of y, we're going to write negative 3x. So 4x minus 2, and then parentheses for the y. Y is negative 3x. That equals 20. Okay, so we've got to distribute this 2. We've got to multiply this 2. We just have to distribute this 2. Negative 2 times 3x, so that's going to be 4x. A negative 2 times 3x is going to be, okay, so 4x plus 6x is 10x. It's going to equal 20. We're going to get rid of times 10 by dividing by 10. So x equals 2. Oh, I forgot to do my over pair. Okay, so we solve this equation for x. So x equals 2. So we're going to fill in our answer for x. Now we've got to figure out y. So we're going to look at both of our equations and use whichever one is easier for us to solve for y. That's obviously going to be the top equation because y is already by itself. So y equals negative 3x. Now, we have a clue as what to do next. We have 2 for x. So instead of writing x, we're going to substitute that 2. Okay, so y equals negative 3 times 2 is negative 6. All right. Oh, I just noticed I made a pretty glaring mistake. I didn't bring my negative down. So that's a negative 20, negative 20, negative 20. That's a negative 2. So now we got to check this. Negative 2. Okay, that doesn't change too much. That just makes 6 a positive. Positive 6. All right, so if you make one little mistake, like I didn't bring down a negative, you just got to back up that mistake. And sometimes it changes everything. You just got to start over. Sometimes it's a real easy fix like that was. So, lesson learned. Okay, so there you go. So that's 3, 6, and 9. In Google Classroom will be how to do the other 6. So just do as many of them as you can in class today. If you have, if you finish, go back and do anything that's missing, or you can start the harder problems on the next page where they're going to be a little bit tougher. All right, good luck.